Hello children, today we will be learning the basics of Chapter 1, Electric Charges and Fields. By the end of this session, you will be able to understand what are electric charges and its types, the basic properties of electric charges, and also the method of charging by induction. Come, let's enter into the chapter. First of all, when you see this picture, what comes to your mind? I think you would all have done this experiment in your previous classes. So when you take a comb and pass it over through your hair for a few times and bring it near bits of paper, what will happen? Yes, as you can see in this picture, the paper will get attracted towards the comb. Yes. Similarly, let's see this. When you take a scale, rub it over your head and bring it near some bits of paper, what will happen? The paper gets attracted towards the scale. What do you think will be the reason for this? How does this occur? There is some force that is pulling the paper towards the comb, right? Or the scale. How is it happening? With these questions in mind, let us jump into the science behind this. Have you all heard this word? Electric charge? In your previous classes? Yes, you are right. We have studied about charge in electricity. Okay. We all know that all objects are made up of atoms. And when you subdivide this atom, that is when you are breaking down this atom, we have elementary particles like protons, electrons, and neutrons. Okay. We know that protons have positive charge and electrons have negative charge. So these are electric charges. By the way, neutrons are neutral. Don't forget that. Okay. Now, how do we define this charge? Any definition, anybody? Charge is the fundamental attribute of a matter like mass. Okay. So charge, it's the property of matter. And this charge is a scalar quantity. What is scalar quantity? The one that has only magnitude or value. It does not have a direction. And we measure it by using the SI unit, Coulomb. Okay. So now coming to the branch of physics that deals with the behavior of this static charges or electric charges. We call it electrostatics. Electrostatics is the branch of physics that deals with the study of static charges, which includes the force exhibited or the field possessed or the potential that arises due to this static charges. Why do we call them static charges? Static means charges that doesn't move. We will be seeing why we say static charges in the upcoming slides. As of now, static charges are charges that doesn't move. That means they will exert a force, but they don't move freely. Okay. Keep the question, why static? We will come back to this later. So now, as we discussed earlier, we know that there are two types of charges. One is positive charge. Another one is negative charge. How do we say a charge positive and a charge negative? You all know the structure of atom, right? So we know that there is a nucleus in the center of an atom, and this nucleus will occupy a distance of around 10 power minus 15 meter. Okay. So nucleus will be occupying a distance of 10 power minus 15 meter. And electrons will be revolving around the nucleus in orbits, right? Okay, the first orbit will have 2 electrons and like second orbit 8 and so on. So now this distance will be around 10 power minus 10 meter. Okay. Can we pull a proton outside this nucleus to give positive charge? No. They are held together by strong nuclear forces. How do we pull them? We cannot pull them. Then how is this positive charge exhibiting? You all have studied about valence electrons. I hope you remember that. They are responsible for transfer of electrons when they come in contact with another atoms. Am I right? Yes? Okay. So, there are few loosely bound electrons in the outermost orbit, which are called valence electrons. When an atom comes in contact with another atom, if it is losing electrons to the other atom, that means it is becoming less negative. We call such atoms positively charged. Okay. Less electrons, losing electrons, positively charged. On the other hand, if it is gaining electrons, more negative charge, so it is negatively charged. This is how we say positive charge and negative charge. Okay, so positive charges, less electrons are losing electrons. Okay, so losing electrons. So negative charges gaining electrons. So how does this losing and gaining happens? It is because of the electron affinity of a material. It depends upon the electron affinity, tendency to acquire electrons or lose electrons. So if a substance has an affinity to acquire electrons, that is to gain electrons, then we call it more negative. If a substance has an affinity to lose electrons, we call it positive charge. Okay. So now the earlier experiment we saw comb and paper. So when you rub the comb over your hair, the comb is acquiring electrons. It is gaining electrons. Okay. So comb is negatively charged. So who is losing electrons here? Hair. So hair is positively charged. Okay. So now here is a table which shows the list of substances due to from various experimental understandings classified as positive charge and negative charge. In the left side of the table, that is in the positive charge, you can see glass rod, flannel or cat skin, woolen cloth, woolen coat, woolen carpet. All these tend to lose electrons. So when they lose electrons, they are called positive charge. And in the right side, you can see silk cloth, ebonite rod, amber rod, plastic sheet, rubber shoes. They all gain electrons. So they are called negatively charged. So these all gain electrons. They are called negative charge, whereas these are all losing electrons. So they are called positively charged. Okay. Is it clear now? Now, coming to the basic properties of electric charge. We all know that like charges repel each other. That is, a negative charge will repel another negative charge. A positive charge will repel another positive charge. Whereas, if a positive charge comes in contact with a negative charge or vice versa, they will attract each other. So opposite charges attract each other, like charges repel each other. Okay. So if you contrast this with gravitational force is always attractive in nature, but here electrostatic forces repulsive or attractive based upon the nature of the charges. Okay. So what is the difference between gravitational force and electrostatic force? You have to understand that there in gravitational force, it is always attractive. The force between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. They are always attractive, but here repulsion also can happen. Okay. So now coming to the second property, charge is always conserved. What do you mean by conservation? You would have studied about law of conservation of mass, law of conservation of energy. So what does all of them say? That is the total number of charges in an isolated system is always a constant. That is, you cannot create charge or you cannot destroy charge, but charge can be transferred from one body to another. Okay, the total number of charges in an isolated system is always constant. That is, the sum of the positive charge will always be equal to sum of negative charge. That is the reason why we say that an atom is electrically neutral. Atom is electrically neutral. Okay. So coming to the next property regarding the quantization of charge. So electric charge is always found as an integral multiple of the basic unit of charge. What is the basic unit of charge? You know that the basic unit of charges for a proton or an electron in magnitude will be E is equal to 1.6021766,208 into 10 power minus 19 coulomb. Okay. So this is approximated as 1.6 into 10 to the power minus 19 coulomb. So the charged body, any charged body will have a total charge of N into E. This minus here is because of the negative charge for an electron. Okay. So you have to multiply the number of charges with the magnitude of the basic charge value, that is 1.6 into 10 power minus 19 coulomb. Charge is always a multiple of this E value. Okay, this E is very, very small number. So this fact that any charged body has a total charge of any, where N is any integer, is called quantization of charge. This E, I told you that this E is a very, very small number. So if you take 1 centimeter cube of copper, 1 centimeter cube of copper, okay, will contain approximately equal to 2.4 into 10 power 24 coulomb of charge. So you know that Q is equal to NE. Okay. Charge is always quantized. So now to find out the number of electrons, if you divide this value by this, you imagine the magnitude of the value of N you will get. It will be a very big number, right? Because that is 10 power minus 19. This is 10 power plus 24. Okay. And if you take a standard bulb for 1 second, there will be 10 power plus 19 electrons flowing. That shows you the number of electrons required for current flow. So in macroscopic level, if you consider charge is always continuous, but charge always occurs an integral multiple of E, it is always quantized. Okay. So coming to the last property of charges, charges are always additive in nature. So it is the algebraic sum of individual charges of the system. That is, for example, if you take a system with plus 3 Coulomb, another with minus 2 Coulomb, so the resultant magnitude will be 1 Coulomb. Or if it is minus 3 Coulomb, then it will be minus 6 Coulomb. So charges are always additive in nature. Okay. So they follow the algebraic addition method. I hope the properties are clear. Charges are always conserved. Charges are always quantized. Charges are always additive. So now coming to the classification of substances, you know what are conductors and insulators, but still we'll have a recap. And the reason for that also I will tell you. We know that conductors allow current to pass through them. So they have comparatively more number of free charges which are able to move freely inside the material. Examples, metal, human body, animal bodies, earth are good conductors of electricity. And insulators are substance which offers high resistance to the passage of electricity through them. Example, glass, porcelain, plastic, nylon, wood, etc. So now, I told you the word static earlier, right? Yes. So what is the static electricity? And whatever substances what we saw, plastic, comb, glass rod, wool, all these are coming under the category of insulators. So is that only insulators can be used for studying the phenomena of static charges? Static charges are charges that are at rest. So if you spray some charges on an insulator, will the charge be able to move? It will stay in the same place. There is no freedom to move for the charges that are sprayed over an insulator. Whereas, if you put some excess charge in a metal, what happens? The charge will get distributed to the entire surface. Yes, exactly. The charge in a conductor gets distributed through the entire surface, over the entire surface. Whereas in an insulator, it will stay in the same place. Now, so that means, ma'am, is it like only we can use insulators for testing static electrostatics? No, if you wanted to use metal, for understanding electrostatics, you have to insulate the metal from the surroundings so that the charges cannot get discharged. They don't reach the ground. Okay, so when you are using metal spheres, you are supposed to disconnect it from the, isolate it from the surroundings. Okay, so methods of charging. So how do we charge a particular material with a particular type of charge when we require it? 3 methods. Rubbing scale over your hair or combing hair with a comb. What happened there? Rubbing, friction. So charging by friction. Okay. So charging by friction means charging by rubbing two substances against each other. Charging by conduction. Conduction means by touching each other. When you touch two substances each other, the charge gets transferred from one body to another body. Charging by induction is the third method, which is part of your curriculum, and we'll be seeing that in detail. Inducing a particular type of charge in a material, in a body. How do you induce We'll see how to do that. So now here you can see there are two metal spheres, right? Two metal spheres. They are placed very close to each other, and as I told you earlier, they are insulated from the surroundings. Insulated. Okay. So this is the first step. Now I have brought two metal spheres and they are very close to each other. They are insulated from the surroundings by some insulator strands. What will be the next step? I need to induce a particular type of charge there, right? You know that opposite charges attract each other. Like charges repel each other. Keep that point in mind. With this, let's see what is happening in the next part. Now see, I have brought a glass rod with a particular type of charge. So now here it is positive charge. Opposite charges attract each other. So all the negative charges in the sphere are getting attracted towards the positive charges that are being close in the sphere. And all the positive charges are getting repelled. They are moving to the other side. Okay. Here what is happening? Attraction. Okay. So now let's see the next step. Now we are increasing the space between these two. Even then what happens? The negative charges towards the positive charge and the positive charges away from the positive charge. Same, the force of attraction and repulsion is playing a very important role here. So now what will happen if I remove this glass rod? These two charges, you can see here very clearly, right? Yes, these two charges, they are moving close to each other because they are opposite in nature. Okay. So now, if I wanted to make a particular charge on the surface, though I increase the distance, they get distributed evenly on the surface and they stay there for a very short interval. Okay. This is how you are charging a substance with the required particular charge by induction. Now here one sphere, as we have taken two spheres, one sphere is, the sphere that is far away is positively charged and the sphere that is closer is negatively charged. The reason is because I brought a glass rod which had positive charge. If I would have brought a negatively charged substance near the sphere A would have been positively charged and B would have been negatively charged. So let's see the next part of this method. How can you charge a metal sphere positively without touching it? So I wanted to charge a metal sphere positive without touching it. What will I do? So I need only one sphere. I will take a sphere. I will insulate it from the surroundings. Then I'll bring, because I need positive charge, what should I do? Very good. I should take a negatively charged substance near that. Okay. So I'm taking a metal sphere, insulating it from the surroundings. Now I am bringing a negatively charged substance. Okay. So now the opposite charge come closer and the like charge will move to the other side. I need to remove this negative charge now because I want only positive charge. I don't want negative charge. What should I do now? I should ground it. Yes. So now I am grounding it. So what happens? All the negative charge will discharge to the ground. Okay. So now what happened? Next step, you can identify very clearly. Once you remove this glass rod or negatively charged substance, what happens? They will be distributed evenly on the surface. Even after removing the ground in this picture, you can see that there is only positive charge because the negative charges are discharged to the ground. Okay, I hope this is clear. So now, in case if this question is changed, how will you charge a metal surface negatively? You have to introduce a positive substance here, positively charged material, so that it becomes negatively charged. Okay, so that you have to read the question, understand it and do it. So now with this, we have completed the contents of today's session. Let us have a small test to check our understanding. So when a glass rod is rubbed with silk, as we saw from the table, we understood that it will donate electrons so that it becomes positive. Glass rod becomes positive and silk cloth becomes negative because silk has a greater affinity to acquire electrons. So the answer will be B. Okay. So what are the basic properties of charge? Charge is always conserved. Second property, quantized. Third property is additive. You have to expand it and write, don't write short words like this. Okay. And like charges repel. Unlike charges attract. Okay. Let's see if there are any other questions. Yes. How will you charge a metal sphere negatively without touching it? So you need to take a sphere, insulate it from the surroundings. Now introduce a here negative, right? Negative. So introduce a material with positive charge. So now what happens? Negative charge will come to this side. Positive charge will go to this side. Now the next step is to keep this as such. Negative, negative, positive, positive. Ground it. The next step will be after grounding, what happens? Only the negative will be staying here. As soon as you remove this negative charge will be distributed throughout the surface. Okay. You should explain these type of questions only with diagrams and corresponding theory. Don't write only theory without diagrams. You have to draw the diagrams. So practice the diagrams accordingly. If you have any doubts or any questions regarding this session, please drop your questions in the comment section. We are happy to help you. Thank you.